Assalamualaikum. My name is Muhammad Danish Maulana from Group 4. Today I want to present about bottle filling and capping system using ultrasonic proximity sensor. Next. Okay. The background of instrumentation and control system in plastic bottle filling and capping. Filling machines are machines used in the packaging business to fill containers with liquid, gases, paste, or powder. Capping machines are used to cap material filled bottle. So, using PLC and mechanical assembly, we create a system to illustrate the filling and capping system used in industry for bottles. The method combines filling with a piston and syringe arrangement with capping with a motorized arrangement, all in a single machine. The complete assembly is made up of a conveyor that transports empty bottle to the filling head. The filling head is in charge of filling bottle with water. Eventually, this assembly pushes the bottle into the circling disc, which transport it to the capping station, where a cap is placed on the bottle. The bottle arrives at the cap turning station, which is a mechanized mechanism in charge of rotating and tightening bottle caps. Following this, the assembly moves to the bottle to the next stage, where it is rolled down the system as a finished product. To operate the whole system, we employ a PLC-based system with sensor and motorized assembly. The picture above is the block diagram of closed-loop control system. We have user in controller, output processor, and repeat again in sensor if have error. Okay, next. Now we go to the hardware description. In bottle filling and capping system, we using PLC. A PLC is a digital electronic device that employs a programmable memory to store instruction and execute operation. It is to make the programming easy, and the input receive digital or analog signal from the sensor are turns them into a logic signal that the CPU can use. So it make easy the programming. Next is software description. For filling bottle and capping, we use PLC. Ladder diagram, also known as ladder logic, is the most commonly used programming language for PLC. This is the graphical language that presents the logical links between input and output. Ladder diagram are virtual circuit in which virtual power passed via virtual contacts when closed to activate virtual relay coils that execute logical operation. Next slide for me. Next.
Detail of proposed instrumentation, ultrasonic sensor, specification and detailed information of the sensor. Ultrasonic proximity sensor are a common type of proximity sensor used in many manufacturing and automation applications, mainly for object detection and distance measurement. They are commonly used in food and beverage processing and various packaging applications. Ultrasonic sensor work by using sound frequency higher than the audible limit of human hearing, which is typically in the range of 25 to 50. The sensor sends out an ultrasonic pulse and get a pulse back in the fundamental physical principle of ultrasonic sync. The distance to the object can be calculated using the time difference between the send and receive signal. Although they can alternately be placed in distinct components like some photoelectric sensor which separate emitter and detector. The transmitter and receive frequency built into the same physical cases. It is easy to install and cable when the transmitter and receiver are housed in the same device. Next, we go to material used for the sensor. Piezoelectric crystal, also known as electroreactive crystal, are nickel ferric aluminum alloy, are the primary component of ultrasonic sensor. A piezoelectric ultrasonic sensor is a reversible sensor that generates ultrasonic wave by converting electrical energy into mechanical oscillation. Additionally, it has the ability to transform ultrasonic waves that are received into electrical energy. A piezoelectric chip housed in a plastic or metal container serves as the ultrasonic probe central component. The performance of each probe varies depending on the material used to make the chip and the dimension of the chip, such as diameter and thickness. They are before utilizing it. We must be aware of its performance. The following are the primary performance metric for ultrasonic sensor like working frequency, operating temperature, and sensitivity. Next.
Okay, next we will move into the working principle for this project. So my name is Muhammad Shafiq Aiman bin Ibrahim, and I will present about the working principle. Okay, firstly, this filling and capping system is the machine produce a faster way to fill the bottles than manual filling and is more economical. So the automatic plastic bottle filling and capping machine is use PLC, which is known as program logic controller. That is computer control system that continually assess the status of input device and decide how to regulate the state of output device based on the bespoke program. So this is the flowchart of working principle. And this is the schematic diagram for this project. So the working principle for this project is the machine start by switching on the button on the machine. So the conveyor belt started to move when the DC motor has been started to move in a rotational way. The conveyor belt will carry the empty plastic bottle to the filling area. After that, the empty bottle will detected by ultrasonic sensor, and then by detection of the ultrasonic sensor, the nozzle of the water will function at the perfect time. PLC will manage how full the plastic bottle is, allowing the user to fill it to the appropriate amount. When the bottle has been filled, the conveyor belt will move the plastic bottle to the capping station. The rotating cylinder will move by the power of the stepper motor to the cap mounting. So the cap mounting mechanism will move downward and exactly fit and place on the top of the plastic bottle cap. The plastic bottle will stop so that the DC motor can tighten the cap by rotating motor of the DC motor. Next, the rotating cylinder will again continue the rotation of the plastic bottle to the conveyor belt so it can move to the box to be delivered. Okay, so this is the block diagram for filling and capping system that is a closed loop system. And this system will run continuously when the switch is on and will stop when the switch is off.
So, Assalamualaikum and very good evening to the audience. We have seen this presentation of our groups. My name is Muhammad Aiman Safwan bin Bakri, and I will be the next presenter who will present about the advantages and also the limitation of ultrasonic sensor. So let's see. As you can see at our slide here, ultrasonic sensor have a lot of advantages instead of the limitation. And the first one is ultrasonic sensor have the advantages of sensing with high accurate. Ultrasonic sensor are able to detect minute change in location with great accuracy. it is because of how they function itself. And ultrasonic sensors also can detect a range of material. And next, ultrasonic sensors can detect irregular objects, liquids, dense material with rough, smooth, or light surfaces, and transparent objects. And the last one is, mm, since there are no moving elements in ultrasonic sensors, they are fully wave-free and have a longer lifespan than contacting counterparts. And now I will tell you about the limitation of ultrasonic sensor. Even though we have complete faith in the abilities of our sensors, we are aware that not all applications are best served by ultrasonic technology. And there are a few of the sensors limitation. And the first one is it cannot work in a vacuum. Ultrasonic sensors utilize sound to function. Thus, since there is no air for the sound to pass through in a vacuum, they are utterly useless. Other than that, temperature variations of at least 5 to 10 degrees can impair the accuracy of the sensor. Despite the fact that this is true, we offer a range of temperature compensated sensors that, depending on the sensor type, calibrate either before each range reading or at sensor startup. And the last one is the sensor also have a limited detection range. I think that's all for the advantage and limitation of ultrasonic sensor.
Next is predictive maintenance planning, or PM. So first step we must do is get familiar with ultrasonic. So we must know the basics and how to operate the ultrasonic. Next, we must understand the proper configuration and methods of using ultrasonic. After that, we must identify the critical component. So we can identify the critical component by using CMMS software or computerized maintenance management system. After that, we can identify the problem with the series of questions. The question we can ask such as, does the operation have decrease in the production? Does this operation have adverse environmental effect? Or does any defect occur in the operation? Next is for the baseline and inspection analysis. For this, we can record and save any testing and using it as a baseline. With this, we can use it as a reference and use as a comparison in the future. Lastly is the documentation and action, which is we must take several records and to ensure it was accurate. Next, if any significant changes happen, it should be saved and inspect later. Lastly, we can use PDM or predictive maintenance planning by using CMMS software to serve as a warning sign to do inspection before anything failure in the system.